Hello friends, today again I am here with one more important topic of engineering chemistry, and that is lubricant. We are going to discuss on this topic lubricant because it is highly important for the exams, and moreover this topic is very easy to understand. And today I am going to cover some of the, or rather all the topics needed for this chapter. Okay, so let me start with the first one is the definition. These are the topics we are going to cover in this video. The first one is the definition. The second one, what are the functions of the lubricant? Okay, why we are going to use the lubricant in the different purpose. And then we are going to talk about the properties needed for the lubricating substance. Can we use any substance as a lubricant, or we want some specific properties into that? We are going to discuss. Then what are the different type of lubricant possible? In our syllabus we have 3 different types. We are going to discuss one by one all of them. And at the last, the most important topic of this chapter is the mechanism, and that is how the lubricant is going to work. So let's start with the definition first. So let's start with the definition of the lubricant as well as lubrication. Now we are going to discuss in a very basic and very fundamental way so that anyone can easily understand this. Okay, now what is the definition of the lubricant? Any substance placed between two moving surfaces or sliding surfaces to reduce the friction is known as lubricant. I can understand that anyone can visualize this. Suppose this is one metallic surface moving in this direction. That is another metallic surface moving in opposite direction. So they are basically sliding with each other. Now if I put some amount of lubricant in between, so what will happen? The metal contact become metal lubricant contact, and this lubricant is purely to reduce the friction between the two moving surface, and that is the role of the lubricant. So lubricant is a substance which can reduce the friction between two sliding metallic surface or sliding any two different surface, okay, moving surface. Now we go for the another definition, and that is lubrication. Okay, now what is the definition of the lubrication? It is the process. This is where the important is. It is the process of reducing friction between two metallic sliding or moving surface by the introduction of the lubricant. Okay, this process, by using the lubricant we are trying to reduce the friction. This process is known as the lubrication. Okay, so with these two definition we are stopping here. Now we are going to use that what exactly the purpose of lubricant. Go. So let's talk about the functions of a lubricant. Okay, because we are now applying a substance between the moving surface which reduce the friction. We already understood this. Now what are the other function or other purposes solved by this lubricant? Let's discuss that. So first one, it reduces the wear and tear loss. I hope anyone can understand this because now there is no metal contact. Now in between the two metal contact the lubricant came. So because now it is metal lubricant contact, so the chances of the mass loss or the wear and tear loss will be minimized. Second one, it reduces the frictional heat. Obviously, because since it reduces the friction, so the frictional heat generation will be less. So in one word, I can say the lubricant may act as a coolant material. Then the third one, it increases the efficiency of the machine, because now there is no loss in the mass, there is no heat generation in the machine. Obviously it is going to enhance the efficiency of the machine. Obviously it will reduce the maintenance cost. It makes the relative motion of sliding parts noise free. Now this is something interesting. Noise free, as I said, if there is a friction it will create noise. So now since there is no friction, so we can understand the reduction in the noise. At the last, it gives corrosion of metallic surface. It avoids the corrosion of the metallic surfaces during shutdown. That is another important purpose of the lubricant. Now you think about a condition where the machines in shutdown mode, machines is not working. So what happened, most of the times we saw that metallic parts are facing the corrosion which is not desirable. Now if I apply the lubricant which creates a layer at the top of the metallic surface and avoid the contact with the surrounding moisture or oxygen, obviously the chances of corrosion become less. So these are the different purpose of lubrication. Okay, I hope one can take a note on that. Now we go for that, what are the criteria that you are looking for a substance to become a lubricant. So let's talk about the properties of the lubricant. It means I'm going to discuss that before choosing a lubricant, it should have some properties associated with it. So we are going to discuss not all the properties but few important properties. Let us discuss one by one. The first one is the viscosity. Okay, that is very important parameter, viscosity. Now what is viscosity? Let us understand first. It is the property of a liquid by virtue of which it offers a resistance to its own flow. Now how you understand this? We'll understand, like if I take two beaker, in one beaker we have a oil, another beaker we have a water. Now if I put a 1 rupees coin in both the beaker, then we have noticed that the coin in the water will fall first and the coin in the oily medium will fall later. Why? Because the oil have more viscosity than the water. This is what we understand. If the viscosity is less, the flow property is high. Now why this parameter is very important? Because we are putting the lubricating oil between the two moving surface. If the viscosity is very high, then lubricant itself will create a problem or incorporated to the resistance. But if the viscosity is very less, then what will happen? The lubricating oil will flow from its own place. Both the cases not desirable. So what do you want? We want, if you see, for a good lubricating oil, it should have moderate viscosity. It should have a moderate viscosity. Viscosity should not be very high, should not be very less. Now the second condition. The second condition is the viscosity index. In short, it is known as VI, viscosity index. So we have seen that very often that the oil change its flow property or with the increase in temperature or decrease in temperature. In one word, if I increase the temperature, the viscosity reduces and the flow property increases. And if I decrease the temperature, the viscosity increases. So we have seen in most of the oil, or rather lubricating oil, they changes their viscosity very quickly with the temperature, and which is not desirable. And this parameter is known as the viscosity index. So let's have a quick view on exactly what is the definition. The rate of change of viscosity of an oil with the change of temperature is known as viscosity index. So the rate of change. Now what we want? We don't want the change in the viscosity very fast with the increase in temperature. Why I am emphasizing more on the increase in temperature? Because we understand the working condition where two metallic surfaces will slide each other, maybe with high speed or low speed, does not matter, but temperature will increase. Now at that high temperature condition, we don't want that viscosity of the lubricating oil should change much. So we want is, you can hear, I have noted this, okay, that for a good lubricating oil, the viscosity index should be high. So you can take a note on that also. Okay, so with this we discussed our first property. We are going to discuss few more properties now. Now let's discuss our second important property, and that is known as the flash point and fire point. Before I going to discuss the importance of the flash point and fire point, let us understand the definition of the flash point. it is the minimum temperature at which the lubricating oil or the lubricants gives enough vapor to cause a momentary flash when a standard test flame brought near to it. We have to understand this. What happened? Suppose the lubricant were working to moving metallic surface. Due to the friction, temperature goes high. Now what happens if the temperature increasing, the lubricating oil, they are volatile, they gives you vapor. Now the vapor keep on increasing and there will be a certain temperature at which that lubricating oil will give you a momentary flash when a test flame brought near to it. And if I further increase the temperature, then the lubricating oil, okay, you understand, may catch fire. Lubricating oil gives enough vapor to catch fire at least for 5 seconds when a test flame brought near to it. So what happened? This two parameter is highly important. Lubricating oil working condition is vigorous because temperature goes high. If the temperature goes high, it may happen that lubricant may catch fire. Now before catching fire, we saw that lubricating oil give a momentary flash. It means that is the flash point. And if the further temperature increases, then it may happen that lubricant will give the enough vapor to catch fire for at least for 5 seconds. That temperature will be considered as a fire point. Now from this discussion, two things we understand. One, fire point is higher than the flash point. Okay, we have to understand this, that fire point is higher than the flash point. That is, we have to understand. Okay, and we usually, it is around 5 to 40 degree more the flash point than the fire point. Sorry, fire point than flash point. That is one thing. Second one, that what is the significance of this flash point and fire point? To understand the temperature range up to which we can work. Basically, it is related to the safety concern. Suppose my working condition is 200 degrees centigrade. It means the lubricating oil I am going to use, it should have the fire point maximum up to 170 or let's say 180, not more than that. Otherwise, the accident will cause. So for a better or a good lubricating oil, we expect that for a good lubricating oil, okay, the flash point and have fire point should have very high flash point and fire point. That we need to understand. For a good lubricating oil, the flash point and fire point need to be very high. Higher the flash point and fire point, better is the quality of the lubricating oil. Now we are going to discuss just opposite to that. Now we are going to discuss just opposite to the fire point and the flash point. Like you think a condition where the temperature is very low. The places like Siachen, the places like Kashmir, the places like Antarctica, where the temperature remain far less than the 0 degrees centigrade. So there also we need to consider a condition where the temperature is very low, but my lubricating oil or the lubricating oil that we are applying between the two moving surface should work properly. And because of that, we need to know the cloud point and the pour point. Now what is cloud point? Cloud point, it is the minimum temperature at which the lubricating oil shows a cloudy or hazy appearance is known as the cloud point. I think one can easily understand if I give the example of the coconut oil. Now what happened to the coconut oil? If you see, if I slowly decrease the temperature, the coconut oil, this shows a cloudy or hazy appearance. That temperature is known as the cloud point that temperature is known as the cloud point. But what will happen if I further reduce the temperature? If I further reduce the temperature, the lubricating oil will cease or stop to flow. It will solidify. It will stop to flow. Not desirable. That temperature is known as the pour point. So which one is higher? Obviously the cloud point is higher than the pour point. Okay, cloud point is higher than the pour point because slowly you are decreasing the temperature. Now what is the significance of that? The significance, again, I hope you understand that for a good lubricating oil, it should have low cloud point and pore point. The minimum the cloud point and pore point, better is the quality of the lubricant. Okay, but again, it depends on the condition. Okay, so with this, we are done with this property. Now we are going to discuss totally different another property. Now we are going to discuss that the acid value of the lubricating oil. The question is coming, how the acid generates in the lubricating oil. Now you can see the lubricating oil, mostly we are using either mineral oil or vegetable oil. If we heat them for a long time, either in presence of air and oxygen, they convert into the weak acids. Okay, they convert into the weak acid. This is how the acid produce. Okay, so let me repeat, the lubricating oil working for a long time at high temperature in presence of air or oxygen, that lubricating oil will produce the acid. Now the question is coming, is that acid is desirable? Right answer is never. Because if the acid will produce, it may cause the corrosion to the metallic surface, which is not desirable. And that is the reason, if you see at the bottom, I wrote that good lubricating oil should have the acid value less than 0.1. Acid value should not cross the value 0.1. If it is less than 0.1, okay, we can use it further. If the acid value is more than 0.1, we cannot use it. Now the question is how to calculate the acid value. We are going to tell you very shortly. But before that, let us understand the definition of the acid value. Okay, let us understand the last definition. It can be defined as the number of milligram of KOH required to neutralize the free acid present in 1 gram of lubricating oil. As I said, that lubricating oil, I took 1 gram. I just wanted to see how much acid is present. Now to understand the acid, we have to titrate with the base, and that is the reason we took potassium hydroxide. And now you can see the definition again. It is the milligram of KOH required to neutralize, because KOH is a base, acid we are titrating, acid base reaction, neutralization reaction. So the milligram of KOH required to neutralize the free acid present in the lubricating oil. Okay, so this is the definition of the acid value. We discussed how the acid generates, and we also said the significance of the lubricating oil. So now we are going to discuss that how to calculate the acid value, and from there we will do one quick numerical. So now, as I said, we need to find out the value, acid value present in the lubricating oil, and this is the working formula. That acid value is the volume of KOH into the normality of KOH into 56 divided by the weight of the oil. So this is the formula to find out the acid value of any lubricating oil. Now why the volume of KOH? As I said that we are measuring the acid, and acid will be titrated with the KOH. So we'll get the volume of KOH from the titration value. Normality or the strength of the KOH, and then 56. 56 is the molecular mass of the potassium hydroxide, and then weight of the oil. So from this kind of numerical you can expect. Okay, you can expect this kind of numerical. Purposefully I have given, find the acid value of a vegetable oil whose 10 ml required 4 ml of 0.01 normal KOH during titration, and the density of the oil is also given. Okay, so these are the information. Now I already told you that how to do a numerical. To do the numerical, we have to follow 3 simple steps. No matter you're doing the numerical of chemistry or physics or anything. First, given. Second is equation, and third is the calculation. So let us see what are the values are given. So the volume of oil is given. Okay, volume of oil. Okay, volume of oil is given, and that is 10 ml. Perfect. required 4 ml, so that is the volume of KOH. Okay, volume of KOH is 4 ml, that is given. Acha, normality of KOH is also given, 0.01 normal. Okay, now if you see that this is our working formula, that acid value is volume of KOH. We have the volume of KOH here. Normality of KOH is also we have. Then we don't have the weight of the oil directly. Now to calculate the weight of the oil, we have the another formula, and that is density is equals to mass by volume, or I can say that mass is equals to density into volume. So we have this value, density is given, that is 0.92, volume is 10, so you'll get 9.2 gram. So this is the mass of the oil. Now let us, since we have the formula, I am not writing the formula again, so let us put the value to calculate the acid value. Okay, so acid value equals to, what is the volume of KOH? Volume of KOH is 4 ml. Normality is given, that is 0.01, already given in the numerical, into 56 upon 9.2. So the answer will come 0.243 milligram of KOH per gram of oil. So this is the unit of the acid value. Okay, so you can see, so the value is 0.243. Now the question is coming, can we use this lubricating oil for a further purpose? Right answer is never, because the value is more than 0.1. Since the acid value is more than 0.1, you cannot use it further. Okay, so with this we are done with the acid value. Now we're going to discuss again one more important parameter. Now we are going to discuss one more important parameter which is bit different from the others, and that is saponification value. The word saponification word came from the saponify, and saponify came from the soap formation. Okay, so let's understand what exactly the definition of the saponification value. It can be defined as the number of milligrams of KOH required to saponify 1 gram of vegetable or animal oil. Understand? See, the vegetable and animal oil contains the esters of fatty acid. That is something special. All animal and vegetable oil, they contains the ester of fatty acid, and this ester of fatty acid have a tendency to react with the alkali to give soap. That is the reason the name gives saponification. Here also you can see the KOH is basically an alkali. I am not writing here because I don't want to disturb the definition, but understand the reason behind the word saponification. Because the vegetable oil and the animal oil, they contains the esters of fatty acid. These esters of fatty acid react with the KOH and give you the soap. Now, what is the significance? Why you are going to need this saponification value? You can see two important significance are here. The first one, it can determine the presence of animal or vegetable oil in the lubricant. What does it mean? It means, suppose if I give you a sample of lubricating oil and I try to understand whether this lubricating oil contains the vegetable oil or animal oil, we have to perform this saponification test. If I am getting some value of the saponification, then we have to understand this lubricating sample contains the vegetable and animal oil, because the saponification value for mineral oil is 0. That is another important thing, that because the mineral oil does not contains the esters of fatty acid, and that is the reason they cannot show the saponification value. So this is the significance, that in one word the saponification value for the mineral oil is 0. for a lubricating oil, whether they contains the animal oil or the vegetable oil, we can understand by this saponification value. Now, since it is associated with the word value, we should know how to calculate the saponification value. Again, I am going to tell you the equation of the saponification value, and from that we'll do a quick numerical. So now, as I said, saponification value have an equation to find it, the value. So we have an equation to find out the value of our saponification. So let's see the formula. Saponification value is the formula is V2 minus V1 ml of KOH into the normality of KOH into 56 divided by the weight of the oil. Okay, so this is the formula to calculate the saponification value. Okay, now what is, we already know what is normality of KOH, discuss 56, we know weight of the oil, we can understand. What is new in this equation is V2 and V1. So let us understand what is V2. V2 is the volume of HCl for blank titration. What is blank titration? Blank titration means without sample. That is the reason it is known as blank. Now, what is V1? Volume of HCl for back. Back titration means with sample. Okay, with sample. And you always understand that V2 is higher than V1. Okay, because for the blank titration, we have all free KOH. But for back titration, we have the less amount of free KOH because some of the KOH will react with the vegetable oil or animal oil. Okay. Now, from this, this kind of numerical may come in the exam. So, what is that? 2.5 gram of vegetable oil was mixed with 50 ml of 0.4 normal KOH. Okay, perfect. The mixture required 26.4 ml of 0.4 normal HCl. The blank titration reading was 49 ml. Find the saponification value. So from this numerical, you can understand that all the informations are given. Okay, so let's start V2. So V2, because I have already written the equation, I am not writing it again. So I am requesting to all of you, when you are doing this kind of numerical in the exam, you have to write the equation and then you have to put the value. Okay, so now V2 is given. V2 will consider 49 ml because this is the reading for the blank titration, clearly written. What is V1? V1 is 26.4 ml. Okay, 26.4 ml is given. Okay, what is the normality of the KOH? Everyone can notice that 0.4 normal. What is the weight of the oil is also given, 2.5 gram. Everything is straightforward. Okay, everything is straightforward. Now what we'll do, we'll put the value directly into the equation. So saponification value is V2 is 49 minus 26.4 into 0.4 into 56 divided by the weight of the oil, and the weight of the oil is 2.5 gram. Okay, weight of the oil is 2.5 gram. So if I do the calculation, I'll get 202.49 milligram of KOH per gram of oil. Okay, see the unit for acid value and saponification value is same, because here also you have a volume, normality by weight. So this is how we can do. This is very simple numerical, very straightforward numerical. You have to follow 3 simple steps I am telling you. The given value, equation, put the value, do the calculation, give the answer with the unit. Okay, so this is all about the properties of the lubricants. Now we go for another segment. So let's discuss another different segment of this topic, and that is the types of lubricant. Now if you see, the lubricants are of 3 types depending on their state. One is the solid lubricant, we have a semi-solid lubricant and liquid lubricant. Now, depending on the end use, we have to pick up that which one is the best in that condition. Depending on the end use means purely we are talking about the kind of situation depending on the load and the speed. Okay, we are going to discuss one by one. By the way, let's start with the solid. Now, solid lubricant is mostly the graphite powder, molybdenum disulphide. They are the example of the solid lubricant. They comes as a very beautiful powder. Now, why they act as a lubricant even though they are solid? It is purely because of their layer by layer structure. And between the two layers there is a weak van der Waals force of attraction, and that is the reason they shows the slippery property and act as a beautiful lubricant. Now, sometimes the graphite and MOS2 were the condition. Let us talk about the condition where we are going to use the solid lubricant, where the condition is vigorous, like the temperature generation is bit high, where we can expect that semi-solid and liquid cannot sustain. In that high temperature condition, we need the solid lubricant. So the graphite shows the thermal stability up to 375 degrees centigrade, whereas molybdenum showing around 400 degrees centigrade has a thermal stability. Sometimes this solid lubricant we are using by mixing with the water. When we are mixing with the water, it is known as aquadag. When we are mixing the graphite with the oil, it is known as a oil dag. Okay, so this is something about the solid lubricant. Remember, both graphite and MOS2 shows this layer by layer structure, and between the two structure there is a weak van der Waals force of attraction. That is the reason that slippery nature, that lubricating nature generates. Come to the semi-solid. Now, semi means half. Now, semi means it is having the state where half solid and half liquid. That is the reason the name is given semi-solid. The most common semi-solid lubricant we are using is the grease. Very common. Okay, that is grease. Apart from the grease, Vaseline can be another alternative or another example of the semi-solid lubricants. Now, question is coming, where we prefer the semi-solid. We prefer the semi-solid where the load is high but the speed is less, like the rollers, the tractors. In that condition, we prefer to use the semi-solid lubricant. Apart from that, where we don't want the dripping of the liquid, like I don't want to use the liquid lubricant because I want to avoid the dripping condition. In that situation also, the semi-solid lubricant are the best. Now, as I said that semi-solid lubricant, the best example is the grease. Now, let us quickly discuss that how you are making the grease. The grease can be made very easily by if you take the vegetable oil. Now, here the vegetable oil are of very inferior quality, like we are using the vegetable oil like eucalyptus oil, turpentine oil, pine oil. Okay, inferior quality vegetable oil, because ultimately what we are making the grease. So vegetable oil, we are adding the alkali. Now this alkali or the base react with the fatty acid. We already discussed the esters of fatty acid react with the alkali and forming the soap and the glycerin. Now this soap basically act as a thickening agent, because now this soap we are adding with the petroleum oil or the mineral oil. This soap react mixing with the petroleum oil and gives you the end product is a grease. Okay, now the properties of the grease we can change by adding some different additives. If I want more higher thermal stability, we can add some inorganic filler like the talc. Okay, now come to the grease. Now grease are of different type. It is grease again are of different type. Let me talk about, like it may be a calcium based grease, it may be a sodium based grease, it may be a lithium based grease, it may be a axle grease. There are different type of greases possible. Now who decide that whether it will be a calcium or sodium or lithium? It's purely depend that what kind of alkali you are using. If I'm using calcium hydroxide, then it will be known as calcium based grease, or cup grease. If I am using sodium hydroxide, then it will known as a sodium based grease or soda based grease. If I am using lithium hydroxide, then it will be known as a lithium based grease. Okay, so what kind of alkali you are using, that will give you the name of the grease, and not only that, obviously the property is going to change from the moment I am changing the nature of the alkali. Because if I say calcium hydroxide, okay, calcium hydroxide alkali, if I am using, calcium will give you very good water resistance, but on the other hand sodium hydroxide based grease give you high thermal stability but poor water resistance. On the other hand, lithium hydroxide gives you both the property, water resistance as well as thermal stability, where we can change the temperature stability of the lithium based grease by adding some additive. So this is how the grease is formed, okay, and this is all about the semi-solid lubricant. Now come to the very famous liquid lubricant. When it comes to the liquid lubricant, the very common, we are using either vegetable or animal oil or mineral oil. Okay, we know the difference between them. The basic difference between the vegetable and animal oil with the mineral oil is the oiliness. The oiliness of the vegetable oil is very good with comparison to the mineral oil. Okay, but if you talk about the viscosity, then the viscosity of the vegetable oil is very high with comparison to the mineral oil. Now, it is not possible to have all the desired property. Now if I say what kind of lubricating oil we want the lubricating oil with moderate viscosity, we want very good viscosity index or high viscosity index, we want the flash point and fire point need to be high, we want the cloud point and pore point need to be low. Okay, so all this desired property we cannot have in a single oil. Okay, it's not possible. For that we are going very often with the blending. As I said, you are using mineral oil, but we want very good oiliness, so we can add the vegetable oil with the mineral oil, so we'll get both the property. That is called blending. Suppose I want very good viscosity index, high viscosity index, like which we don't want that lubricating oil should change its viscosity with temperature. In order to have the very good high VI, we can add the polystyrene or the hexanol. So these are the example of the blended oil. Now come to the last one, is the synthetic oil. Synthetic lubricating oil, where we need a very specialized condition. In a very special condition, I want a lubricating oil which should have a high thermal stability, like 200 degrees centigrade is the condition, but at the same time I don't want that it should change its viscosity, and the working condition is high. So to this kind of situation where we need very specific quality of the lubricating oil, we go very often with the synthetic oil. Okay, so all these things are the different types of lubricant, and now we are going to the very last part, but very important, and that is the mechanism of lubrication. So now we are going to discuss the most important part of this topic, and that is the mechanism of lubrication. Now lubrication mechanism is of three types. One is known as a thick film or fluid film or hydrodynamic lubrication. Second one is thin film or boundary lubrication, and the third one is the extreme pressure lubrication. Now the first question should come in our mind, that why we need three different type of mechanism. This is purely depending on the situation where we are going to use it. If the load is less and the speed is moderate, then we can think about the thick film lubrication mechanism. If the load is very high but the speed is less, like rollers and tractors, we can think about the thin film lubrication mechanism. But you think a very vigorous condition where the load is very high and the speed is also very high, like the stone crushing machine. Okay, in that kind of situation, the temperature goes very high and we need to follow the extreme pressure lubrication mechanism. So now we are going to discuss one by one very slowly in a very basic way, starting with the thick film lubrication mechanism. Now thick film lubrication mechanism mostly where the load is less and the speed is also less. like the sewing machine, like the electronic instruments. Okay, we have the like the watches, the two hands of the watch, they are also revolving around the so center. So all these places where we can go for the thick film lubrication mechanism. This is something critical, because here you can see between the two moving metallic surface, in between that we are keeping a lubricating oil, and the thickness of this lubricating oil is 1000 angstrom. Okay, it is 1000 angstrom is the thickness, and that is the reason the name is given thick film lubrication. So you can see the metal contact, now it is become metal lubricant metal contact. So this lubricant play a very important role, because the lubricant should have very good oiliness, so it should stick to the surface first, so that it will be remain at its place. Number one. Number two, the lubricant should not have very high viscosity or not very low viscosity. It should have a moderate viscosity. Okay, so it will solve the purpose, because the coefficient friction, the moment I am applying the lubricant, see that coefficient of friction become very low. In that case it is 0.001 to 0.03. Okay, whereas if I am not using the lubricant, then the coefficient of friction become 0.5, very high. Okay, very high. Now what is the coefficient of friction? One thing we need to understand, that coefficient of friction is directly proportional to the frictional force. Higher the coefficient of friction, higher we need the friction or frictional force. Okay, so the best lubricant is that where we can get the minimum coefficient of friction. Now to understand this thick film lubrication mechanism much more better way, I took an example of the rotation of a shaft or the journal. You can see now this bearing at the outside, inside there is a shaft, and we know that shaft or journal, they will rotate inside that. Now it is now at rest. Okay, now it is in rest. Now what happened, I am going to apply a lubricant here. Okay, I am going to apply a lubricant. Now what will happen, look at here, that the moment the journal or the shaft started rotating, it is slowly that there is a bearing, and that shaft will come in between, still rotating, and in between the shaft and the bearing, that lubricant will create a film. Okay, the lubricant will create a film. Now you can see that metal contact is avoided by this metal lubricant contact. So this is why this lubricant or the choosing of lubricant is very crucial. So most of the times we are going with the petroleum oil. Okay, sometimes the low viscous vegetable oil, but in order to maintain its viscosity throughout the year, because in the year we have different kind of season, winter, summer, there is a variation in the temperature. Sometimes we are adding some amount of polymer to that in order to maintain the viscosity. So this is all about the thick film or the hydrodynamic lubrication mechanism. But you think a condition where the load is very high. So if you want, I can write here where the load is very high. In that condition, you cannot go with the thick film lubrication mechanism, because the oil will spill out from its own place. So because the load is very high, the metal contact will come very close to each other, so we have to apply a lubricant here. Okay, the lubricant we are applying between the metal, and this thickness is only become 10 angstrom because of the very high load. Okay, because of the very high load up to contact, okay, the thickness become very less. See here we go for especially with the semi-solid lubricant. We can go with the solid lubricant as well. Okay, in that condition. Now here the coefficient of friction again goes down to 0.05 to 0.15. Okay, so this is where the thin film lubrication, why the name is given thin film, you can understand the thickness is very less, 10 angstrom. Why the thickness is very less? Because of the very high load. Okay, so this is the thin film or the boundary lubrication mechanism. But here one thing we need to discuss, that we prefer how this oil stick to the surface. That is again important. In the first case I said the oiliness of the lubricating oil need to be high. What is here? Here we prefer the lubricating oil should have a very long hydrocarbon chain as well as have some polar group. So polar group have the affinity to the metal surface. So there we can expect a physical force of attraction or the absorption will take place, so that the lubricating well will be there between the two moving surface. Okay, now come to the vigorous condition. Now the last part of this entire video is the extreme pressure lubrication mechanism, where the load is very high, maybe the speed is also very high. I already discussed like the crushing machine. Okay, the crushing machine where you can expect that huge amount of load and speed. Here the temperature is very high. Here the concern is the temperature. We cannot use any normal lubricating oil. Why? Because if I use any normal lubricating oil, they cannot sustain at that high temperature. So what you are doing with the, along with the lubricating oil, we are adding some additive here. Okay, we are adding some additives like chloride or chlorine, sulfur, phosphorus. This kind of additives we are adding with the lubricating oil. Now what is happen with that? Now this chlorine, sulfur, phosphorus at that very high temperature, they will react with the metal surface and form a chemical lubricant. With the chemical reaction, they will form the metal chloride, metal sulfide or the metal phosphide and stick to the surface firmly. They will create a very thin layer, very thin layer, and there is a chemical reaction with the metal surface. Now since there is a chemical reaction you are expecting with the metal surface, we need to be very careful. The metal, if the metal is inert, they don't want to react with this chloride, sulfur, phosphorus. Okay, so with extreme pressure lubrication, as I said, we are going with the additive. This additive reacting with the metal surface, forming a lubricating oil or lubricating film between the two moving surface and solve our purpose to reduce the friction. So I hope with this kind of we get a overall, okay, we got a very overall idea of this lubricant chapter, because we discussed so many things. We discussed the definition of the lubricant and lubrication, the purpose of using a lubricant, the different types of lubricant, the mechanism, the properties, everything in a very basic way. And I hope this video certainly helped to all the viewers. Thank you very much. Namaskar.